Term 1 Vectors, exam question, January 2008, question 6. I've already done the first two parts of this question, which are sort of relatively straightforward. Particle moving with a constant velocity, and we're asked to find the speed. So if you remember, the speed is the magnitude of the velocity. So I've just done Pythagoras theorem and got root 89, which works out to be 9.43. Now we're also asked the direction of motion. So minus 5i plus 8j means that we're moving up in this direction here. I used trigonometry to work out this angle theta. The opposite is 8, the adjacent is 5, so it's the inverse tan of 8 over 5 that we're interested in, which rounds off to 58 degrees. So this section in here is 58 degrees. And because this line I've drawn here is west, that's 270 degrees. So 270 add 58 tells us what the angle is here. Remember, bearings are always measured around from north, and that gives us 328. So that's the first part of the question completed. For part C, we've got to look at the different phases of the motion of this object. So the particle starts with a position vector 7i minus 10j. And we know from the first part of the question it's going at minus 5 plus 8j, and it does that for 3 seconds. So it's minus 5i plus 8j, and it's doing that for 3 seconds. So if we work that out and count the number of i's and j's, it works out to be minus 8i plus 14j, and that's the position when t equals 3. So remember, we're using that formula, R0 plus V times T. Now, it says after a further 4 seconds, moving with this new velocity, we get to the origin. So minus 8i plus 14j plus a new velocity times 4 gets us to the origin, and the origin is 0i plus 0j. So using this, we can work out the values of u and v. So let's look at the i's. We've got minus 8 plus 4u equals 0. U therefore must be 2. And from the j's, we've got 14 plus 4j 4v, sorry, equals 0. So working that out, 4v is minus 14, so v must be minus 3.5. So that's part C completed. For part D, we've got to work out how long it would take for this particle that's moving along to move from its starting position to a position which is due south. Now, if you remember, the starting position, if we go right back up to the top, was here, 7i minus 10j. So A is the point 7i minus 10j. That's 7 along and 10 down from the origin. Now, if something is due south of this point, it must have the same I component. It must be 7 along, but perhaps further down, more than minus 10. So what we're looking for is the I component being equal to 7. 7 along and something else further down, which makes it south of this point. Now, if you look back to this line here, we know that after 3 seconds, it had hit the origin. And the formula there, I'm just going to adapt it slightly. We know that u is 2, so it's 2i, and we've got minus 3.5j. Now, after 3 seconds we're at this point. Our new velocity is this. We're going to do that for a certain number of seconds, and we'll get to the stage where our I component is 7. So let's work out what we've got here for the general position vector. We're going to have minus 8 plus 2ti and we'll have 14 minus 3.5 tj. That's its general position at any given point in time. Now this is the crucial part. We want that to be equal to 7 in order for it to be due south of this point. So we know that minus 8 plus 2t would have to be equal to 7. Add on the 8, 2t is 15. So t must be 7.5. Now we have to be a little bit careful, that's not quite the answer. It says find the total time for P to move from A, which was the very starting point, to a position which is due south of A. Now we know that to get to this point here took 3 seconds. And if you look back at the calculations we did earlier, it started at A, 3 seconds at the original velocity took us to this point. And then from that point, we've done some more time at a different speed, which gets us to the point we want. So the total time altogether then is the original 3 seconds it took to get to this point here, plus another 7.5 seconds at the new speed. And so the answer is that it would take 10.5 seconds in total.